Hi, welcome to my channel, The Magic of Math. Today my math lesson is on adding and subtracting polynomials. So if you're not a subscriber, I hope you will be after today and sign up for notifications as I progress through the unit of learning about polynomials. And we're going to end the unit by factoring. So I hope you'll come back for more. So here we go. Today, our objectives are that we're going to find the degrees of monomials, we're going to classify polynomials, and we're going to learn how to add and subtract polynomials. It's kind of like a tongue twister today for me. And here's the question I'd like you thinking about. What rule must you follow when you are adding and subtracting polynomials? So there's a couple of things, and I think everybody's a little bit different, but there are definitely some must-dos and hopefully some big takeaways for you today. So first, let's go over what is a monomial. It's a big word. So a monomial is a number, a symbol, a variable, or the product of a number and one or more variables, and they have to have whole number exponents. So this is going to be key as you move through and try to determine what is and is not a monomial. And I'll get further into this in a minute, but monomials you've been using your entire life. You know what they are, you just never heard them referred to as that before. The number 5 is a monomial, so it's a single term. 6xy, that is a term. It's a product of 6 times x times y. It's numbers and variables. That is a monomial. 1/3 times x squared still has a whole number exponent. This is a monomial. It's a term. X, a single variable. 1x, invisible ones here, monomial. And 2 pi x. So remember, pi is the placeholder for a value, and we use pi because the number is never ending, so it would be impossible to write it down, so we use a symbol instead. But this is a term or a mathematical expression that is also a monomial. Let's talk about some things that aren't monomials. X plus 7 is not a monomial. There's two terms here. You cannot have a monomial with an addition or subtraction sign. So that is not. 5 over x is not a monomial because we have x in the denominator, and what you've learned previously is this is equivalent to x to the negative 1. And remember, we have to have whole number exponents. Negative 1 is an integer, but not a whole number. So that is not a monomial. We have 4 to the x. The exponent is the variable. That is not a monomial. And negative 3. You cannot have negative exponents. So that is not a monomial the way it's written. Now, if you wanted to write this as 1/27th, that's a monomial. Okay. So, not monomial, so we're looking for whole number exponents. The variable can't be an exponent, and the variable cannot be in the denominator. The next we're going to talk about degrees of a monomial. So that is the sum of the exponents of the variables in the monomial. So the degree of a number is 0, except 0. 0 doesn't have a degree, okay? So let's talk about this. So we have the number 8. That degree is 0, okay? So the reason that is, and let me show you the next one and I'll prove to you why. So 5x has a degree of 1 because this x has an exponent of 1. So if you were going to write a variable term here, I could put next to the 8, x to the 0. So x to the 0 is equal to 1, okay? So really there's an invisible 0 here. 8 times x to the 0 has a degree of 0 because the exponent to that variable would be 0. Here we have that invisible 1 giving us the degree of 1. 1/2 xy has a degree of 2 because I have x1, x with an exponent of 1, and y with an exponent of 1. Remember those invisible exponents. So they add up together to be 2. So you add them if there's more than one variable. The number has a degree of 0. So we have a degree of 2 for this monomial. Here I have 12x squared y, monomial that with a degree of 1 plus 2, giving me 3. Here, 7a squared b squared, I'm going to add the exponents, and it has a degree of 4. So right here, don't forget the invisible 1. I have an invisible 1 video out there you should take a look at. 1 plus 4 gives me a degree of 5. So if you need to come back and look at this, you could pause and take a look. But this is what it is. You're looking for the variables. And remember, you could write x to the 0 here because x to the 0 is 1. So the exponent would be 0. All right, your turn. I'd like you to pause, find the degree of each monomial, come back and hit play when you're ready. Welcome back. Let's see how you did. 1/4 has a degree of 0. Remember, all numbers except 0 have a degree of 0. 16a to the 4th b squared c has a degree of 7. An invisible 1 plus 2 is 3 plus 4 is 7. The term or monomial xy has a degree of 2. Invisible 1 together have a sum of 2. And the last one, we have one variable term with an exponent of 3, so our degree of that monomial is 3. Okay, let's move on. Let's talk about polynomials now. A polynomial is a monomial or sum of monomials. So each term of a polynomial is a monomial. That's a mouthful. So basically, what we're talking about is a monomial is a polynomial, but then we can add even more terms all together, and it's a polynomial. So the number of terms in a polynomial is used to classify it. So here we have 4x. That's one term, and we call it a monomial. Let's look at 3y subtract 4. That has two terms, 3y and negative 4. We call that a binomial. One more here, we have x squared plus 5x plus 3. So I have three terms, x squared, 5x, and 3. And it's in simplest form. None of those are like terms. So it's in simplest form, three terms, and we call that a trinomial. Keep in mind, these are all in simplest form. You want the polynomial in simplest form before you classify it. These are all polynomials. More specifically, we could call it monomial for one term, binomial for two terms, trinomial for three terms. So often students look at me like, oh my goodness, this is crazy. Polynomial, monomial, binomial, trinomial, what a mouthful. But remember back, we're just building on your math knowledge. Remember you learned about quadrilaterals. I bet you the first time you heard the word quadrilateral, you're like, oh my goodness, I can never do this. But you quickly learned about rectangles and squares and parallelograms. This is no different. We're just classifying algebraic expressions. So if you have one term, it's a monomial. Two terms is a binomial. Three terms is a trinomial. Anything else, four terms here, we're going to stop here. Anything more than three terms, most teachers would have you call a polynomial. If you get really nitty-gritty, there are some people that will call a quadrinomial, which is very much a mouthful. And you could keep on going. Some people have, mathematicians have gotten very specific, but typically the ones you hear, monomial, binomial, trinomial, and then everything else is considered a polynomial. Keeping in mind, these are also polynomials. So to call all of these a polynomial is correct, but we can classify it by its number of terms. Okay, so when we go to talk about the degree of a polynomial versus a monomial, which is just one term, we want to have the polynomial in standard form. To write a mathematical expression like this, a polynomial in standard form, we want our exponents to go in descending order. So the caboose, the term furthest to the right, is typically a constant, or if you don't have the constant, the number, you're going to end with x to the first, that invisible 1. But you want to start with your highest exponent and work down. Now you might not have a 2x squared term here, but x cubed plus 5x minus 2. So it might skip They might skip when you're going in descending order, but it goes in descending order, okay? So when we do this, once we have our polynomial written in standard form, then we're going to be asked about things like the coefficient of the polynomial. And we call this the leading coefficient. And this will become very important later on as you get into Algebra 2 and further courses. But here we just want to introduce some vocabulary. So this first term is the one that holds the leading coefficient. So here the leading coefficient is 1. Remember, there's an invisible 1 there. So the degree of the polynomial is the highest degree of any one term. So right here, because we have it in standard form, this first term has a leading coefficient of 1, and this term has a degree of 3, giving the polynomial a degree of 3. So it's really important to understand how to write one in standard form because the first term identifies the leading coefficient and the degree of the polynomial. All right, your turn. Here are two mathematical algebraic expressions, to be more exact, two polynomials. I want you to write each of these in standard form, classify them, meaning monomial, binomial, trinomial, or just plain polynomial, but as specific as you can get, identify the leading coefficient, and identify the degree of the polynomial. Go ahead and pause and come back and hit play. Welcome back. Let's see how you did. So I'll go through the first one. In standard form, x cubed comes first, plus 3x, subtract 2. So my exponents are going down. They're descending. 3, 1, 0. Okay? Classify it. It's a trinomial because it's a polynomial with 3 terms. So we're going to call it a trinomial. The leading coefficient is 1, and the degree is 3. All right, the second one was already in standard form the way it was given to you. Notice my exponents are going in descending order. To classify it, this is a binomial because it has 2 terms. The leading coefficient is 7, and the degree is 4. Not so hard, huh? Okay. So now we're going to talk about, now that we know all about polynomials, I'm going to talk to you about adding polynomials first, followed by how to subtract them. So you've probably combined like terms in a previous grade level, but now we're going to start talking about, this is a precursor to before you start getting into quadratic functions. So we have a polynomial, specifically a trinomial, added to another trinomial or a polynomial. So I want you to find the sum. So what we're looking for are like terms. To review that, like terms have the same variable with the same exponent. So the first method I'm going to show you is what we call the vertical method. So that's when you stack them, old-fashioned adding, okay? And when you stack them, you want to stack them with their like term. Then it's just easy to add. 9x squared plus 2x squared, 11x squared. 2x plus 3x is 5x, and 8 plus 11 is 19. So the sum is 11x squared plus 5x plus 19. So that's the vertical method. Here's the horizontal method. Personally, my least favorite of the two methods. I think there's more room for error when we get into subtracting and there's positive and negative terms. But for this one, I'm going to show you so that you're prepared to use it. So horizontally, you're going to want to identify like terms. So I'm going to circle them. 9x squared plus 2x squared gives me 11x squared. Then I'm going to change to squares to identify that these are like terms and their sum is 5x. And then I'll go to triangles. Okay, so everybody needs to figure out a different way. Some people think, I don't need circles, squares, and triangles. I can just add them all together. I find students make the most mistake with the horizontal method, but if that is your method of choice, then that's what you should do. All right, your turn. Pick a method, vertical or horizontal. Go ahead and find the sum of these polynomials. Go ahead, pause, come back and hit play when you're ready. Welcome back. Did you try both methods? That's always a good thing to try. It's hard to say you don't like one way or until you've tried it. So here we go. I'm going to model both ways for you. So here's the vertical method. So here's the trick. When you go to the vertical method, you need to line up your like terms. So because the second polynomial is a binomial with just two terms, there's going to be a missing term here, which is fine. That's just 0. So when we add 4x squared plus x squared is 5x squared. Negative 6x plus 0 is negative 6x. Negative 5 plus 7 is positive 2. So here is our sum. Now let's look at it. Combining like terms, I identify I have two x squared terms for a sum of 5x squared. There's only one variable term with just an x, and then our constants added together are 2. So notice the vertical method gave me the same sum as my vertical method, and my horizontal same. So you can use one to check the other as well. All right, so now we're going to subtract polynomials. This is where you got to pay attention to details. So they're asking us to find the difference. Here's the key thing. You're subtracting every single term in the parentheses. Every one of these terms needs to get subtracted from here. So once again, I love the vertical method. I find it far easier to set up, but I'm going to model both methods for you just in case you like the horizontal method. So the first thing we're going to do is take our first polynomial, and then we're going to stack it. We have our subtraction sign, and all our like terms are lined up. So when we subtract, we're going to do subtract, 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 which hopefully you've had a teacher explain to you that means opposite, opposite, opposite. So subtract 5x squared. When I go to subtract negative x, I end up adding it. Subtract negative x is adding positive x. And subtract 8. So 2x squared minus 5x squared is negative 3x squared. 3x plus x is 4x. And 6 subtract 8 is negative 2. All right. Now let's try it the other way. So if you're going to do the horizontal method, you've still got to do opposite, opposite, opposite. So negative 5x squared, positive x, negative 8. Now I'm ready to look for like terms. So my x squared terms, 2x squared and negative 5x squared are negative 3x squared. 3x plus x is 4x, and 6 and negative 8 are negative 2. So I get the same solution. So the other thing to keep in mind is that when I taught my students to add and subtract integers, we always learned that subtraction was adding opposite. If you learned that and mastered that, this should be easy for you to say, all right, I have to subtract every term in here, which means I'm just going to make them all the opposite, and then all you're ever doing is adding. Your turn. Go ahead and find the difference. Please pause and come back and hit play when you're ready. Welcome back. Let's see how you did. I'll model both vertical and horizontal methods for you. So I'm going to start with negative 2x plus 4, and I'm going to subtract 4x squared. Remember, I don't have a like term to match it up, so it's on its own, and I'm putting it to the left because it has a higher exponent. So I want it in standard form when I'm done. And subtract 5 goes underneath its matching like term. So here we go. Opposite, opposite, and now I'm ready to add. 0 and negative 4x squared are negative 4x squared. Negative 2x and 0, negative 2x. 4 plus 5 is 9. Now we're going to do the horizontal method. So negative, make it opposite, opposite. So now I'm ready to identify. I only have one x squared term, negative 4x squared. Only one x term, negative 2x. And here are my constants. 4 plus 5 is positive 9. So that is polynomials and how to add and subtract them. I hope you enjoyed the lesson. today and that you will come back for future videos. Please subscribe to my channel today and give me a thumbs up. Have a great day.